Hello, this is Pat Kelly. Okay, in this problem, they ask us to solve the equation, and they also mention something about being accurate to 3 decimal places. That's just a little bit of a hint that you might want to have a calculator handy. Not yet, though. Let's start with some algebra. And what I'd always try to remind you is the golden rule of algebra is you can do whatever you want as long as you do it to both sides of the equation. I mention that in this problem because when I recognize that the variable I'm trying to solve for is trapped up in the exponent, my first thought should be, how do I get it out of the exponent so I can solve for it? And that's what one of our properties of logs allows us to do. So I'm going to get that variable out of the exponent by taking a logarithm of that left-hand side, and I'm allowed to do that as long as I take a logarithm of the right-hand side. Okay? So I'm going to go ahead and take the natural log of both sides of my equation here. And right there, I'd like to put a quick asterisk up there as a footnote that I'll come back and talk about a little bit later, because I chose to take the natural log, but you can take log base anything. I'll come back and say more about that at the end. Okay, now I'll go ahead and clean up on the left-hand side. I'll invoke that property of log that I mentioned. We can take the exponent inside of a logarithm and pull it out in front as a coefficient. So I get 3 minus z times the natural log of 2, and the right-hand side is still the same. Okay, trying to solve for z, I'll divide over the natural log of 2. One last step to get that z alone is I'd really be getting the 3 on the other side, but watch your signs here. This is going to look like z equals 3 minus natural log . Okay, and don't you dare even think about canceling those ln's. That numerator is just a single number. The denominator is just a single number. The 3 is a number. So that's all number crunching on the right-hand side. So I'm going to grab my calculator. Just let the calculator do the heavy lifting here. 3 minus the natural log, 625, divided by the natural log of 2. They had mentioned to be accurate to 3 decimal places, so I am getting z approximately equal to negative 6.288. Okay, that's a good answer, and if I could just real quickly come back and address that footnote that I gave you, is when I took the natural logarithm of each side, you could do log base anything, which you might even see in some of your examples in this lesson, is that they would do a log base whatever the base is that you're trying to get rid of. So this could have been a log base 2, as long as you do a log base 2 on the other side. The advantage of that would have been that log base 2 of 2 goes to 1 right away. So it's one less calculation here. That's just a 1, that's just a 1. You can certainly do it that way. I went with a natural log because you'll find most scientific calculators have a natural log button, but they don't have a real convenient, efficient, user-friendly approach to a log base anything other than e, or maybe 10, common log. So use whatever's going to be best for you on your calculator, okay? Okay, hopefully that helps. Hopefully you can do some of the other ones on your own then.